Hello guys, I hope you're all well. I will start with the live session. Now, let's wait for more people to join. Let's start at, where is this? 06, 08. Boom, boom, boom. Okay, guys, we are now live. Let's do the work, right? Please confirm with me that you are able to see the live session. Please confirm with me the live session. Please confirm that you are able to see my screen. Nice. Thank you, guys. So, the work that I need us to do now, we have a lot of work ahead of us. And then we know that this session, it can actually run up until, what is this? Probably 10 p.m. It all depends on how we do with our work, right? So that is that. Let me fix something here. All right. So I'm going to use past papers maybe for the past 3 years. I'm starting with the paper from, what is this place? Northwest. And then I want us to do mainly algebra here and do functions, because from your paper, when we are looking at algebra and functions, they weigh the most marks. So that's why I actually need us to put more effort on those items. Yes, finance and sequences, they are also important, but algebra and functions weighs more. And then what do we mean by that? According to your thing, since your paper is worth 100 marks, your demarcation says algebra is worth, the demarcation is the one that we sent on the group. The demarcation says algebra is worth 30 marks. And then it says functions is worth 30 marks. So from a paper that is out of 100, already these two topics, they're giving you 60 marks, which is heavy, extremely heavy. And then patterns and finance together, they're giving you how much? Let me see, patterns and probability, it gives you the other 40 marks. So that is so doable. So now let's start with the algebra just to cut the time short. Of course, you'll read these instructions, and part of these instructions, one of the most important things is that you're supposed to round off your answers to 2 decimal places unless stated otherwise, right? So this shouldn't be a problem at all. And then the next part, we have the following. So when it comes to this part of algebra here, I expect all of you to be able to get these items right. All right. So please, guys, these ones, make sure that you are able to get them the most marks out of them as much as possible. So we're going to start with the first one. As you see, the first one is 1 mark. And then what do they want you? They want you to factorize, right? So yes, final papers are greedy like that. They can give you something like this and expect you to factorize for 1 mark. This is a final paper, guys. The seriousness of this cannot be overemphasized. So now, when you're a learner who's in grade 10, you know that when you have this, we usually call this a quadratic or a quadrinomial. right? This is a quadrinomial. Then what do I expect from you here? I expect you to be able to open two brackets and then look for factors here, factors of 15 that can ever give you the middle value. So before you do that, you're going to start with factors of the first term. Our first term in this instance is x, right? Factors of x squared, it's x and x. And then afterwards, you look at this term. This term is positive, which means whenever this is positive, it means you must have the same signs in this bracket. So either you're going to have a positive and a positive, or you're going to have a negative and a negative. But you must have the same signs. That's one thing for sure. Right? So judging by 16, the fact that 16 is negative, it means our same sign is going to be negative and negative. Right? Then we want factors of 15. We have 1 and 15. 2 doesn't go. We have 3 and 5. Right? And then what else do we have? We have, yeah, it's just that 1 and 15, 3 and 5. So we want factors that when we add the numbers together, or right, we get a 16. So this and this cannot give us the middle term, which is 16. And then this and this can give us 16. So we have 1 and 15. One mark for those, for everything like that. That's one mark there. We can move on here, right? All right. I hope there are no questions. So let's get another item. Another item here, we have this value here. As you see it. Now, when we are looking at this value, we are supposed to know already what it is in terms of the type of factorization we are supposed to use. All right. So this expression, when you're looking at it, first of all, you want to realize how many terms do you have. And then you can see that you have this term and you have this term. So you have two terms. That's the first thing. And then, okay, you're like, okay, since you have two terms like that, what else do we see? What else we see? It's this situation here. Let me use a highlighter. I have this and I have this. These things, they almost look the same. They almost look the same. So the main difference here is that one of them looks like it's double the other one, right? So which means in this situation, I have a 6 and I have a 2. I can take out a common factor there of 2. So that's what I'll do here. So I already have the a outside. I take out 2 as the common factor. And then inside here, when I took out 2 as the common factor, I'm left with 3a. And then here's a plus. And then inside this part, when I take out 2 as a common factor, the 2 goes out. I'm left with the b. And then I have minus 3 into 3a plus b. That's the first part, right? And then in this first part, what am I realizing? I'm realizing that, okay, wait, here I have this bracket looking similar to this bracket. So this is grouping of terms. So we do that. I take the common factors, I group them together. The common factors are these ones. In fact, same brackets, right? I take 3a plus b, I put them in one bracket, and then these items that are outside, I group them together also. So I have 2a, which is 2a, and then here I have minus 3, so minus 3. So this thing, it's 2 marks. So basically you'll get 1 mark for this bracket and 1 mark for that bracket. Right? I'm sure you guys are working with me. You should be. We can move on, right? All right. Bear in mind, these things of factorization, you'll always have them. You will constantly have them. So the next part here, I'm having to simplify. Now remember, simplifying is the opposite of factorizing. Here, when they said factorize, you do not simplify. Now, what do we mean by do not simplify? I remember in term 1, we used to emphasize this a lot. It means do not FOIL, do not open brackets, do not distribute, do not multiply things. So which means once you, oops, made a mistake there. Once you get to this final step here, this part, most people, what they often do is that they fall into the trap of trying to FOIL this out. And that's the wrong thing to do, because of now it means your final answer will be wrong. Do not FOIL things out. Once you get, when we say factorize, never see yourself foiling, opening brackets, distributing, or multiplying out. And then here, simplifying, it's quite the opposite, which means the final answer shouldn't end with something that is foilable. It shouldn't end with brackets that we can multiply together. It shouldn't end with an answer where we can distribute things. Because of simplifying, it means brackets shouldn't be there. This thing should be, we should be done with it, basically. So here we have this situation, and they want us to simplify that. Right? So this one actually taps on the rule of exponential laws. Now remember what did we say in exponential laws? Let me use this pencil here. In exponential laws, we said whenever I have a raised to b under the a root, let me not use a again, let me use something else, under a c root, right? This goes both ways, right? To a with its exponent, that is b, divided by the weight of the root, which is c, right? Which means I can move from here to there, or I can move from here to there, whichever one I prefer, right? So I'm using now the same principle here. So what happens? I have 27, and now this 27, I want to rewrite it. So you go to your calculator, you press 27, equal sign, shift fact, and then that will give you 3 raised to 3, right? What is 3 raised to 3? 3 raised to 3 is equals to 27. So I'm rewriting 27 in exponential form, right? So since this 27, it had an exponent outside of 2 over 3, I'm going to still put that exponent outside there, right? And what am I seeing? I'm seeing a situation whereby I have 3 multiplied by the exponent outside. Then what happens there? What happens is that numerator cancels denominator. I'm left with 3 raised to 2 over 1. What is that? That is 3 squared. What is 3 squared? 9. And that entire thing, it's 2 marks. It's not 2 marks because they want you to write 2 steps. It's 2 marks because they want you to do everything under 2 minutes, in which I think it will be possible. Exponential laws, guys. We can move forward. Yes, someone says we can move forward. Great. So now, afterwards, you come to this question. Now, I want you to understand that, guys, you're no longer in grade 9. That heavy amount of time you used to have back then during exams, that you'd write a maths paper and afterwards you'll be done and then you start sleeping, that time will no longer be there. Now you'll always be under pressure. Now you are in FET phase. You're no longer in the intermediate phase. Right? So basically, what do I want? Questions like this one, 1.2.2, they have a lot of maths in them, a lot of maths concept. That them being worth 4 marks, it's going to take a lot of your time. Minimum, this thing's going to take you 4 minutes. Can take you 5 minutes, can take you 7 minutes, which is the time now that you don't have. What happens is that now you're going to try this question once, only once. And if it doesn't work out, you move on. Otherwise, you'll be wasting time. Right? Because if it moves you twice, it means now you lost 14 minutes on a question that is worth 4 marks because it took you 7 minutes each time you were doing it. Right? So you try it once. If it works out, it works out. Great. Or you try it once. If it doesn't work out, you leave it there. And then the marker will see what to do with the little bit that you gave him. Okay. So now here we need to be able to cancel things out. That's what we want. We want to see things canceling out so that this thing is left now in its simplest form. So what do I have? First of all, you look at each term, that is it in its most factorized state. For example, I have x plus 3. X plus 3, there is nothing I can do to it. This thing is fully factorized. And then in this situation, you must remember a very important principle, in which the principle says you can only cancel monomials. Now, this looks like a simple thing. This looks like a simple thing to remember. But trust me, many people make mistakes in this because they cancel things that are not monomials. You cannot cancel things that are not monomials, right? Like, for example, this x plus 3 and this x minus 3, I cannot cancel them out. Number one, they are not the same. That's the first reason I cannot cancel them out. One has a plus, one has a minus. Number two, these are binomials. This is binomials, right? Saying what I cannot do, I cannot cancel this x with this x. Why? Because this x, it is in a binomial. And this x also, it's in a binomial. So I cannot cancel them out. I can only cancel out monomials. What do I mean by that? What I mean by that is that if I have x plus 3 over x plus 3, number one, it's not correct for me to cancel them out because of these are binomials. The best way to do that is that for me, I have to put them into one thing with brackets. Now, when I put brackets around them, this is one thing which I can cancel with this one thing. Now, what is another thing I cannot do now? In these situations, I cannot make this one thing, and then cancel this out. No. Because when I'm canceling x and x out, I'm still canceling something that is in a binomial because I'm entering the brackets. When I enter the brackets, I'm entering a binomial. But when I cancel a bracket, I'm canceling a monomial because a bracket now it's one thing. But if I enter the brackets and cancel something inside, I'm canceling something that's in a binomial, and that's not right. You can only cancel what's in a monomial. I hope I said that extensively enough. So what's supposed to happen here? I have this term here, which is x minus 3. I want you to realize that these are binomials and they are not the same. So the first thing I want to do is put them in brackets and make them monomial. Potentially, if I can cancel them out, I'll cancel them out. Then this multiplication sign, there we go. and I have x cubed minus 27. Now, this is factorizable. It's factorizable by what? Difference of 2 cubes. Now, how do we factorize difference of 2 cubes again? I have x raised to 3 minus 27. I have to write it this way. I have to write it as x multiplied by x squared, that is x cubed, minus this one here. This is 9. Wait. Proper. But anyway, it's fine. This is 3 squared. Like, I know what I'm saying. I just want to simplify it for you. 27 is the same as 3 cubed, right? So this 3 cubed, I'm going to write it as 3 multiplied by 3 squared. Do we see that? This is the thinking process on the side, right? So I'll open 2 brackets, one for a binomial, one for a trinomial, right? The sign that's going to be in the binomial bracket, it's the one that is here. It's this sign. So there's a subtraction. It means here I'll put a subtraction, right? And the small factors, they go to the binomial bracket. So this goes here, and this goes here. These are the small factors. And then the bigger factors, they go into the bigger bracket. So x squared, it's the first term here. And because this is the last term, it means 3 squared is also the last term. Right. And then what do I have? I have to find the middle term, because this is supposed to be a trinomial, isn't it? So I'm going to take these numbers and multiply them together. 3 and x, that is 3x. And then now the sign here, it's always positive, always, right? And then the sign here now, it's the opposite of this. What is the opposite of minus? It's positive, right? And then this 3 squared, now I'm rewriting it. 3 squared is the same as what? It's the same as 9. So this is the factorized version of this. That's how you factorize a trinomial, right? So I'm writing this now as a factorized trinomial. I'm going to say bracket, the binomial bracket, x minus 3, and the trinomial bracket, x squared plus 3x plus 9. All over what? All over this denominator here. Now that denominator now is a different story. The denominator is totally a different story, and I'll show you what I mean by that. Like here we are combining different aspects of maths, right? So with this denominator, we have a type of factorization that is called difference of 2 squares, right? And then for you to factorize difference of 2 squares, you open 2 brackets that can take binomials, each of them. And then these brackets will have opposite signs, right? Then we have x squared minus 9. You write factors of x squared, which is x multiplied by x. One goes in the other bracket, one goes in the other bracket. So it's x and x. And then you take 9, you write it in a way that is a perfect square. That is 3 squared. 3 squared, that is 3 multiplied by 3. You take 1 3, you put it in this bracket. Take the other 3, you put it in this bracket. So this is the factorized version of this thing here. So we put it at the bottom. I have x plus 3. I have x minus 3. Right? Then we go to the next thing. What is the next thing? The next thing is that I'm seeing that here I have a division. What am I supposed to do with a division? I'm supposed to turn it into a multiplication. And after turning it into a multiplication, what happens? I invert this such that the numerator becomes denominator and denominator becomes numerator. Let me write it here. I have x minus 3, which is now a numerator. Then I have x squared plus 3x plus 9. And then what do I do? I said that every time I see a binomial, I make it a monomial. So I put it into brackets, right? So now, anything that is above, as long as it's multiplication throughout, can cancel with what's below, only if they are the same. So here I have x plus 3, which actually cancels out with what's below x plus 3, right? And then here I have x minus 3, which cancels out with what's above the x minus 3. Monomials cancelling out monomials. An entire bracket cancelling out an entire bracket, right? I have x minus 3 being multiplied with what? X minus 3. There we go, right? And I'm going to rewrite this now. What am I left with here? 1 over 1, which is pointless for me to write now. Then here, what do I have? I'm only left with this trinomial bracket. That is x squared plus 3x plus 9 all over 1 multiplied by x minus 3 all over x squared plus 3x plus 9. Right? And then what are we seeing here? Oh, sorry, this is cancelled out. This is 1. This, it's 1 because it was cancelled out. Right. What I'm seeing now, I hope it zoomed in much better now. So, and then what I'm seeing now is that I have this trinomial being similar to this trinomial. I cannot cancel them out this way. And I cannot cancel something that is not in a monomial. So I put this trinomial in a bracket. I put this trinomial in a bracket. Then I can take this bracket and cancel it out with this bracket. What am I left with? I'm left with 1 over 1 multiplied with 1 over 1 multiplied with 1 over 1. What is this? This is 1. Is my final answer. No, you won't get penalized for not writing 1 over 1. So you wouldn't have to actually write it. You don't have to. I was writing it so that you can see where did everything go. So the next question here would be, like the question about what we were solving. Where would you get marks? Every time you factorize anything that you have factorized, you get marks for it here. Right? What do I mean by that? What I mean by that is that, let me highlight it. What's happening with my pen? I hope the batteries are not dead. The live session, it has just begun. Oh, there we go. So for factorizing this part, you get a mark. For factorizing this part, you get a mark. Was this factorized? No, it was not. What else was factorized? I think that's everything that was factorized. So afterwards, you get a mark for canceling things out. So this situation, this situation of canceling, like this step where you're canceling things out, you get a mark for it. And afterwards, you get a mark for the final answer. Next part. We can move on, right? Someone is saying the middle bracket, it's not 3x. I don't get it. Oh, I get you. I think you mean on this part here. 3x. That is true. This part here. Missed an x. All right. So, okay, fine. Let's move on here, right? The next thing that we have is a question again about exponents. Now, I need you to make sure that you know these things well. Exponents fall under algebra. So, as part of algebra, you need to master your exponents very well. Very well. So, what are we doing? Here I have 3 raised to x, 3 raised to x. See that? Basically, in my mind, I'm realizing that every term has something that has anything that has to do with this. That's one thing that I'm realizing. And that's what, like, basically when I'm saying this is what I'm realizing, I'm saying this is how you should think tomorrow when you get to the thing, right? So now, oops, zoom in. Now, I need you to remember a law here that says whenever you have a raised to b multiplied by a raised to c, this is the same as a raised to b plus c. And bear in mind, when we say this can move to this, it also means this can move to this. That's what the equal sign means, right? So if I have this, I can get here. And if I have this, I can move back and get this, right? So that's the same thing I want to do here. So this thing here, the first part, this first part here, this one, I'm going to write it as 3 raised to x multiplied by 3 raised to 1. I'm breaking it back to what it was. And then I have subtraction, which is this one. Then I write this part. That is 3 raised to x multiplied by 3 raised to 2. This over this part here, which is 3 raised to x multiplied by 3 raised to 2. A plus sign. Then I have 3 raised to x. Can move on, right? Definitely can move on. So what happens in this situation? In this situation, I need to acknowledge that each and every term has the following. Like this term has a 3 raised to x. The next term has a 3 raised to x. The one below has a 3 raised to x. This one here has a 3 raised to x. This is what they have in common. So since they have that in common, I take it out as a common factor above there. And I'll take it down below also as a common factor. What do I have? Open brackets. If I remove this here, I'll be left with this part here, 3 raised to 1, which is just 3. Minus, if I remove this part here, I'll be left with 3 raised to 2. If I remove this part, I'll be left with 3 raised to 2. The plus sign, I have this thing here. If I take it out, if I take out this from this, I'm left with just 1, nothing else there. So like terms cancel each other out. I'm left with a 3 minus a 3 squared. What is 3 squared? 9. Over a 3 squared, which is 9, plus 1. So 3 minus 9, that's negative 6. 9 plus 1, that's 10. Remember that now you cannot leave your answer as a thing that is not simplified. So you need to simplify this. I can divide this by 2. I can divide this by 2. So here I'll be left with negative 3 over this part here, which is 5. I'm assuming that this is not too terrible. You can't see Hey, how many people cannot see? You cannot see how? My screen is not shared. It's blurry. It's small. I don't know. There's nothing that appears on the shared screen. It's too small, too small. Let's see this if it's visible. I was avoiding to put the screen this way, actually. On computers, it seems small. Okay, let me see how I can adjust it. Is this more visible than the other part? All right. All right, then we'll keep it this way. So, next question. Let's move on to the next question. I'll keep on zooming in this way. I think it will help us much better to see things more clearly. So, next question, it's okay. I'm done with this one. Am I? Yes, I just did this one. Done with this one. The next one now, it's the one below here, solving for x. Algebra is a lot, guys, because algebra is not one thing. Algebra is not just factorizing. It's not just simplifying. It's you doing multiple things. Choose a bigger eraser. Boom, boom, boom. I need more space here. Choose a black pen. Or this one. So, here's what we are working with now. We want to work with this part. And in this part, when we see it, it is 4 marks. Right? This is some collectible 4 marks. Because what I expect from you, is that you should be able to work out that here you have 2 bases and you must sort them out, that you eventually end up with 1 base. So how do we do that? I'm taking it from here now. Right, here we are. So in this situation, what I expect from you now is that I want you to eventually reach the stage of the same base. Here what we see is that we have a 2 being attached to base 3, and then 18 cannot be written in terms of base 3, right? I mean, it cannot be written in terms of base 2, right? Rather, what needs to happen now is that I need to remove this 2 so that I'm only left with 1 base. I cannot deal with multiple bases. What am I going to do? going to divide this part by 2, then divide this part by 2, such that I'm removing 2 as a base. I'm now left with 3 raised to 2x. This is equals to, this situation is equals to 9. All right. And then what happens from here? What happens is that now that I have only one base, which is 3, I can write everything out now in terms of base 3, because 9 can be written in terms of base 3. So how do we do that? I'm going to have 3 raised to 2x being equals to 9 is the same as 3 squared. Now, since the bases are the same, what I can do now is drop the bases. Do not cancel the bases. Just drop the bases, right? We're going to say, therefore, 2x is equals to 2. And now you just solve for x by dividing both sides with 2. This removes that. You're left with x being equals to 1. There goes in your 4 marks. We can move on, right? Next part. The next situation we have, it's this inequality here. Yes, you lose marks for cancelling the bases. Someone is asking me if you lose marks for cancelling the bases. Yes, you do lose marks for cancelling the bases. Please do not cancel out the bases. All right. If there is something you do not understand, you want us to stretch on, please tell me. That's why we are having this live session. That's why I didn't just record a video and send. I want you to say which part are you getting lost on. So here's the question. Let me write it out here. (2.1.2). I have 2x minus 1 all over 3. What is the sign? Greater than or equals to 2x plus 1. Now, when you look at that, what's supposed to happen there? What's supposed to happen is that you're supposed to solve this out. Right? You're supposed to solve this out in a sense that you're like treating it like it's an equation. So how do you do so? First of all, you want to remove denominators. You don't want to work with denominators, right? So I'm going to write it out. This is 2x minus 1 all over 3. And then here's the sign, greater than or equals to 2x plus 1. What do? You want to remove denominator, so you'll multiply with the numerator 3, right? Now, numerator 3 is the same as whole number 3, right? Now your denominator can cancel the numerator. You're left with what? 2x minus 1 greater than or equals to, you distribute this, right? So you have 2 multiplied by 3, that is 6 with the x now. And then you have a positive here, plus 3 times 1, that is 3. All right. And then you keep on solving. You put everything that has excess on one side, everything without excess on the other side. I'm sending this to this side. I'm sending 1 to this side. So starting with this, I have 2x. And then this one, when it comes here, it's now negative 6x. You keep the sign as it is. And then here you have positive 3. And then I'm taking 1, negative 1 to the other side. It's now positive 1. All right. And then here on this left side, what are you left with? You have 2x minus this. That is negative 4x. And then you have this sign again. This is how much? This is 4. All right. So, and then what happens? What happens is that you need to remove the negative 4 from x. All right. To remove the negative 4 now, you are going to divide by negative 4. And this is what I want you to do. Divide by negative 4, divide by negative 4, and then circle this thing so that you do not forget. Why? Because every time you divide with a negative, dividing with a negative, it's the problem. Right? It's the one that causes many things to change. When you divide with the negative, this has to change now. It has to change into a sign that is looking the other way. All right. Only when you divide with a negative and when you multiply with a negative. All right. So what are we having? The negative 4 cancels out the negative 4. You're only left with the x now. And then what happens? The 4 cancels out the 4. You're left with 1 over 1 there, which is how much? Negative 1. There we go. See how doable was that? How many marks was this? This was also 4 marks. Because it's this question here. 4 marks. Love yourself is saying, so say we should just treat the greater than sign like an equal sign unless we multiply or divide with the negative. Yes, that's true. That's true. That is true. Asparity is saying, why didn't we multiply the 2x? We did multiply the 2x. Let me use a highlighter for that. So moving from this step, right, we went to this step here. And that's where we did the things. So to remove this 3, we multiplied with numerator 3. Now that numerator 3 cancels out denominator 3. Now what we do on the left of multiplying with the 3, we have to do on the right by multiplying with 3. And what happens there? We say 3 multiplied by 2x, that is 6x. Right? And then we say 3 multiplied by 1, that is 3. Right? So here, since we cancelled out the 3 on this side, we are left with this part, which appears here. No more denominators. Then we sort things out. We send this to another side, becomes this way. We send this to another side, it becomes this way. I hope I explained where the 2x went. All right, let's move on. Next question. I have to erase these things because I don't really have much space. Where are we? Oh, the nicer part. Still solving for x, by the way. So here I have this one here. And I'm going to write it here. Oh, I need to write the question number so that we don't really confuse ourselves. So this is question 2.1.3. And the question says 2x squared minus x minus 10. This is equals to 0. All right. So now, this is the part where this is peak factorizing. So this is the question whereby if your factorizing is not proper, becomes a problem, right? Because your basic level of factorizing should already be good. What do I mean by basic level of factorizing? Talking about situations like this one here. Remember this, when we factorized it into this one, we are more or less doing the same thing because this is a quad trinomial. However, this usually it happens through trial and error. I do see that this is a quadratic trinomial in which I should open two brackets, right? And afterwards, I write down the things I'm sure of, right? The things I'm sure of is that here I have 2x squared, right? So 2x squared, factors of this thing, most definitely. One part has to be a 2x, the other part has to be an x. There's no negotiating this. This is how it is. Whether where is the 2x or where is the x, it doesn't matter for real. So I'll put them here. I'll put a 2x and I'll put an x here, right? That's a definite part. And then afterwards, I go to the signs, right? What determines the signs of this bracket? It's the sign of the last term. It's basically the last term. The last term is negative. When it's negative, it means I must have opposite signs. One bracket must be positive, the other one must be negative, right? However, now in this situation, I do not know which bracket is positive, which one is negative. So it's a trial and error thing. So I'll just put them here. Bear in mind, what am I saying? This is a trial and error thing. So multiple times you'll try it, it will not work out. And then eventually, as you keep on trying, it will work out. So, and then afterwards, I have the number 10, right? I have this number here, negative 10, right? So since I have a negative 10, I should get factors that will actually give me that negative 10. So that will give me 1, the middle value here, 1, right? Right. So factors of 10, I have 1 and 10. I have 2 and 5. That's it, right? So I test these things out separately. Let me write them here. So factors of 10, we said I have 1 and 10. I have 2 and 5. Right? Now I have to test them. And this is the part that will take you time. So I start by putting 1 and 10 and see where I go. So let me put them here. 1 and 10. So I have to FOIL to see that this works out. So my FOIL here, start with the first terms, this and this, that is 2x squared. Outer terms, this one and this one, that is negative 20x. I can already see it's not working out. Inner terms, this one, it's positive x. And last terms, it's negative 10. So this looks like this, negative 19x minus 10. This is not what I want, which is this situation here, right? So that's not what I want. So now I have to go and try again. Let me remove some small things here. So there we go, right? I have to go and try again, which means this combination, it's wrong, right? But then I have to keep on trying. I have to see what happens if I swap things out. What if I put the 10 here and then I put the 1 here? I swap them around, right? Then we see. So eventually you will see that you actually need to test the outer terms and the inner terms. So that's what we do. Outer terms, it's 2x and 1, which is negative 2x. Inner terms, I have positive x. Right? Do they give me the middle term? I have negative x. So yes, they do. If I put the 10 here and I put the thing here, they do work out that way. Did I do them correctly? I said outer terms, this one, which is 2x and 1, that gives me this. Inner terms, no, I didn't do them correctly. This is 10x, not that. So which means they give me 8x. Right? So they don't give me this. And now I have to try other values. I do the same thing. Up until I learned one of them, right? So I realized that I did these values. I even swapped them around. They didn't work out, right? So now I go to these values and I test them. I put a 2 and I put the 5. Let's FOIL them. First terms, 2x squared. Outer terms, negative 10x. I'm trying to do this fast. Inner terms, I have 2x. Last terms, I have negative 10, right? Then what happens? This is 2x squared, and these ones, they give me negative 8x minus 10. They don't work out. So now I have to swap them around and see if this can work out. So I'll put the 5 here, and I'll put the 2 here. I try them out again, right? Try them out again. Because if there is only one combination that can actually work out, but you have to test these combinations out, right? So I FOIL again. First terms, I have 2x squared. Outer terms, I get negative 4x. Inner terms, I get positive 5x. Last terms, I get negative 10, right? What's happening here? I have 2x squared. I have positive x. I have negative 10, right? It's still not what I want. Why? Because what I want is this, guys. What I want, it is this. And then I want you to pick up something here. You will see that we actually tried all alternatives and we even swapped them around. They failed, right? The next step now is that you need to swap the signs around. Now this part will carry a negative and this part will carry a positive, and see how things out. You try these numbers again, all of them. You even swap them around again. So now let's do that. I have first terms 2x squared, outer terms plus 4x, inner terms minus 5x, last terms minus 10. This gives me 2x squared. I add the like terms, minus x minus 10. This is what I want. So my combination is this one. That's how factorizable it should be, right? So these are my factors. As for how long will it take you to get there, that is up to you. That is up to you, but you have to test them out. All the ones that are possible. You see, the more you do these types of factorization, the more you might even be able to see which ones are possible. Right? So what happens here? Now, this you have to write it as, remember this was an equation. Which equation was it? It was this. This entire trinomial that you see here, this entire trinomial was equals to 0. So we do that, equals to 0, right? And then afterwards you do the factor rule. Remember, you take each bracket, you equate it to the right, or x plus 2 is equals to 0, right? So you're going to have 2x is equals to 5, or you're going to have x plus, okay, 2 goes to the other side, negative 2. This is already solved, all right? Then afterwards, you come to this part, you're going to say x is equals to 5 over 2, because you're going to divide both sides by 2. And there you get your 4 marks. The shortcut to this is doing more of them, and then eventually you'll see the pattern on how to do them. Eventually you will see how this actually works out. Like, it's like an instinct thing. The more you do them, the more you will see that, okay, it's not necessary for me to try a combination of 1 and 10 for me to end up with this, because we have a 2 in front. Like, it's a skill thing. The more you do it, the more you do this type of factorizations, the more you'll see which ones are doable. Right, we can move on from this, right? Okay, the next part. Now, with us being here, I want you to understand the nature of setting a question paper. Have you realized that so far we did all these nice questions? All of them were doable. All of them was something we know. There will always be this one question, right? Towards the end of the topic of algebra, as you're solving your question paper, there will be this one question. Minimum, it will be 4 marks, like this situation here. Minimum, it will be 4 marks. I mean, if they are kind on you, that question will be 3 marks. Worst case scenario can be 5 marks. That question will be a level 4 question. And that question, you'll know it when you see it. Like, you don't have to search too long for it. You will know it when you see it. It's towards the end. Usually it's the last question or the second last question, like we see it here. That question will be doable to you or not doable. But whatever you do, you try it once or you look at it once. And if you see, you look at it to check if you understand it. And if you don't, move on. Because you don't want to spend too much time on something you don't know. Things you don't know do not get you marks. Only the things you know get you marks. Right? You move on from the things you don't know because they will make you lose a lot of time. Move on from those things and go to the ones you know. Right? Skip that question. Okay. But then let's try this one and see how possible or impossible it is for us. Let's zoom in. This is 4 marks, by the way. Are you guys processing it? I just put it here so that you guys can process it before I do it. So you can form some ideas around it. And then you analyze if this is the question you'd be able to do or not. So remember we said how much is algebra on the paper? We said algebra is 30 marks. Right? Out of the 30 marks, I want you to get worst case scenario, 23. Worst case scenario. Are you guys done thinking? Can we do 2.2? Have you done it on your own first so that we can do it? I have my own thinking around it, and it might be different to yours. But once I say it to you, I think if I explain it to you, I think you'll be able to understand what do I have in mind. They're saying how much must be added to this number, right? So that it can be equals to this number, right? So, like basically, I have two numbers, and they're telling me that they're not the same. One is bigger than the other, and I want to know how much am I missing here so I can get to the next question. So, number one, I cannot see what is this question. Like, let me remove some highlighters here. I cannot see what I have here. I have to work around it. All right. So, what does that look like? I'll say a number on my left hand side, that is x plus 5 and x plus 5. That's what I have. So let me turn this into something I can understand. So I'm trying to brainstorm here. I have x squared. What am I doing? I'm foiling, right? First terms, they give me x squared. Outer terms, they give me 5x. Inner terms, they give me 5x. Last terms, they give me 25. Right. Now let me simplify this further. What am I getting? I'm getting x squared, right? Let's move this up because I think comments might hide this from you. You won't be able to see, right? Like terms are giving me positive 10x plus 25. So on my left hand side, this is what I have. Let me write it here, in fact. On my left hand side, I have x squared plus 10x plus 25. This is the number I have. Now the next number, I'm going to write it in red so that there can be like a bit of a difference. I'm going to say on my right hand side, I have the following number, which is this one. What is this number? This is x plus 1 and x minus 25. I'm sure by now you can see the idea. Where am I going with this? Oh, yes, I hear what you're saying. It's supposed to be x plus 5 and x minus 5. Okay, let me fix that. Thank you, guys. Thank you, Mpumza Wise. Let me fix that. All right, this is supposed to be x plus 5 and x minus 5, which changes the whole narrative. I don't know how I missed that, but let's put a minus here, right? Basically, okay. In fact, I just have to do this over. I just have to redo it. The left-hand side, I have first terms giving me x squared, outer terms giving me negative 5x, inner terms giving me positive 5x, last terms giving me negative 25. I don't know how I missed that negative. Therefore, my left-hand side is equals to x squared. Negative 5 and positive 5, they cancel out. Then I'm left with x squared minus 25. That's my left-hand side. Right? Thank you, Ratile. And afterwards, I do my right-hand side now. Right? My right-hand side, let me also make sure that I don't make a mistake on this one. My right-hand side, I have x plus 1, x minus 25. So when I expand it, okay, it's expanded. When I FOIL this, first terms give me x squared, outer terms give me negative 25x, inner terms give me positive x, last terms give me negative 25. All right. And then what am I getting? Right? What am I getting? I'm getting my right-hand side being equals to x squared minus 24x minus 25. All right. Now, do you see how beautiful is that? Because of now we are working with something that we can actually see. This is my left-hand side. Right? This is my right-hand side. And now from here, it should be possible for me to answer the question. Right? These are the two values that were meant to be the same. And then it says, how much must be added? How much must be added for the two values to be the same? Now look at that. How much must be added for those two values to be the same? How much must be added on this number, which is the left-hand side? How much must be added on the left-hand side for us to get the answer that's on the right-hand side? Anyone? Thank you, negative 24x. And that's how you answer the question. Right? You're going to say, therefore, negative 25x must be added to that value that you see. Boom. There we go. See, how nice is that? You just had to reinterpret the question and answer. It's just a tricky question. But once you see it, you would actually see that, oh, it's doable. It's not something you would have done in class. It's not something that I can prepare you and say your level 4 tomorrow is going to look like this. No. I cannot actually know what your level 4 will look like tomorrow. Right? I just know that it's going to be a tricky question that needs you to think a little bit. And then if you find it, you find it. If you don't, it's fine. Just keep it and go to the things you can do and save yourself some time. Negative 24. Yes, thank you. Not 25. What am I doing? Negative 24, not 25. We can move on, right? And now we can do simultaneous equations. All right, let's move on. Let me erase this. So simultaneous equations. Remember now that with simultaneous equations, basically, how can I put this? Simultaneous equations, you have to identify your equations, then find the third one. There are two methods to do simultaneous equations. I always do one method because that's the method you are going to carry to grade 11. The first thing, you identify your equations. Let me use this other space because I need a lot of space. All right. So I have this first equation right here, which says y is equal, it says y minus 3x is equals to negative 2. Boom. That's equation 1. You identify that immediately as equation 1. And then you're going to say 7x minus 2y is equals to 8. Boom, that's equation 2. You have to do these things of dots and showing this is equation 1 and show that this is equation 2. Then afterwards, create equation 3. Equation 3, now you look at these two equations. You look at the equation where you can quickly isolate one variable, any variable, right? Look at the two equations and see which equation has one variable that you can quickly separate from everything else, right? When I'm looking at this situation favors me because at this point, I can quickly isolate one variable there. Easy. This thing will not be a problem. All right, so let me try to do that. You show us there that you're taking this equation and you're creating equation 3 with it. You leave y on one side equals to negative 2, and then you transpose negative 3 to the other side, which becomes now positive 3x. Boom. That's equation 3. All right? You've isolated y. As long as you isolated one variable, that's enough. That's your equation 3. Okay. And then afterwards, you skip one line. And then you tell us what are you doing. I'm going to say, I'm subbing my equation 3 into an equation I haven't used. So this equation gave me equation 3. Now I have to sub equation 3 not on the one that I've already used, because of equation 3 comes from equation 1. So I'm going to sub equation 3 actually into the one I haven't used, which is equation 2. So sub equation 3 into equation 2. You see what am I doing? I'm guiding the person who's marking. I'm showing him that on this step, I'm subbing equation 3 into equation 2. Then what do? You write for me equation 3. You write for me equation 2. 7x minus 2y is equals to 8. You show me this is equation 2. You show me the raw equation 2 first. Then afterwards, you substitute into equation 2. Now, what are you saying? You are saying to me, every time you see y, you're going to replace it with this binomial. Every time you see y, you replace it with that binomial. That's how you sub equation 3 into that. Let's do it. 7x minus 2, where there is y, I do what? I put the binomial. Negative 2 plus 3x. This is equals to 8. Then what happens? Then here you just do maths here. Here, then now you're just applying maths. I have 7x. So negative and negative, that's positive. 2 times 2, that is 4. Then you distribute to this one again. Negative and positive, that's negative. 2 and 3x, that's negative 6x. This is equals to 8. All right. Then what happens? Then you work with the like terms. What are like terms in this situation? Let me choose a different color for it. I've been abusing this highlight. This and this are like terms, right? So when you add them together, you're left with just x. 7x minus 6x, it's x. Plus 4, this is equals to 8. Then I'm transposing, right? X is equals to 8 minus 4. Therefore, x is equals to 4, right? You found your x. Then you skip a line again. So this is one part. This is one part. Now you're going to the third part. You're going to say, substitute your x value into one of the equations. But you want to choose the simplest equation. And usually that equation, it's equation 3, because it's already, one of the things it's already isolated. Then whatever you spoke about here, you write it down. Equation 3, it's this one. You identify it. Remember to identify your equations. It's very important. Then you sub x. Y is equals to negative 2 plus 3. Where there is x, you'll put what? You'll put your x value there, which is 4. You're going to have what? Negative 2 plus 12. Therefore, your y, is equals to 10. Boom. This is the third part and the last part. See how doable is that? We can move on, right? Karabo says, I think we need 3 hours for maths. Don't worry, you'll get what you're crying for. When you get to grade 11 next year, final paper is 3 hours. And it's not easy to finish. Can we go to functions now? Don't worry, we still have 2.5 hours. Still have 2.5 hours. It's not enough, yes, but it's something. All right. So that's what we did there. As you all can see, I think that person was right. We have to do functions because these other things will be able to do them on your own. Like, they will be doable. Just take this paper, continue with it the same way we we did this one. Just time yourself, make sure that you actually time yourself. It's very important. And then solve these questions out. Just practice these patterns, practice this finance, and you'll enjoy it. Right? I think I find this question interesting. I think I find it fascinating. It's a functions question, even though this is a heavy question to start with, but let's do it. Right? Sir, please do fast. I want to watch Skim Sam. Skim Sam is already over, Chief. It's 7:30 now. What time does Skim Sam play? It's over now. So this question, you have to internalize it. See what type of a thing you have. And then this one needs a little bit, some small preaching for us to get to it. Just a small level of preaching here so that we can be able to remember things. Now, here we are working with, I don't know how I can do that. This will be a lot of work. Okay, I'll just write on top of everything. When you have functions, especially this one specifically, you're working with a hyperbola. Right? This is a straight line function. Right? We are going to start with the straight line. A brief history about the straight line. Brief revision. The general equation of a straight line is this way. Some people do it this way. In actual functions, actually, the right general formula is this way. But it doesn't matter because there's no penalty. In fact, there's no mark for any formula. Right? In drinking water, Chief, you have to, whenever you're studying for longer sessions, you must drink water. And I had Monster during the day, so I have to drink lots of water. Monster is bad for you. Very bad. Right. So now, here's what we have. We're saying this is the general equation of straight line function. And with the general equation, what we know, let's put this here, is that this is the y-intercept, right? Where the graph crosses the y-axis, right? And then this is the gradient. And how do you find the gradient? You use a formula that says m is equals to y2 minus y1 all over x2 minus x1. This is what we know, right? Things are usually straightforward with these things, with a straight line. So it's usually not a problem. So now we have to go to the hyperbola. Now the hyperbola is the one that has some theory behind it. Now for grade 10, let me try to remember. For grade 10, yes, the general formula says, because there is grade 10 content and there is grade 11 content. Yeah, right. This is grade 11. You see what I'm talking about? A over x plus q. This is a general formula for grade 10, right? And then the only things you have to remember here are that this is your asymptote. Right? This is your asymptote. What is the asymptote? It's this line. It's the line that the graph will never touch. Right? And then remember, this graph has two asymptotes. There are two lines this graph is not touching. Right? You have this part here that the graph is not touching, and then you have the y-axis. The y-axis, it's also the asymptote. It's always the asymptote at grade 10. So you have two asymptotes. You have the y-axis, and you have this one that I'm talking about, right? And then this thing here, the A tells you the shape, right? And then if it tells you the shape, what does it tell you? It tells you whether on a Cartesian plane, your graph will be this way, or it tells you whether your graph will be this way. You see, these are two different things. For example, whenever you have your graph having this shape this way, it means your A value is positive. That's all. Doesn't matter the number. And then whenever your graph is this way, your A is negative. Right? Are we good? So if it goes to the direction of your left hand, it's negative. If it goes to the direction of your right hand, your A is positive throughout. So that's the role of these two items. Again, this is the asymptote, this is the shape. All right. So now let's move on. So here's the thing here. We have the graphs of f of x. All right. So usually in these situations, if you walk into the exam and then you have a highlighter, just use your highlighter this way. So you can be able actually to, your eyes will be able to pick up this thing fast. Right? When we say graph of f, you'll quickly remember that graph of f is the green graph. Right? And then afterwards, you have this situation here, whereby you have the graph of g. And then you just highlight that with a different color. There you go. So you have a situation like this, you know that you are working with this. And then afterwards, you want to make sure that every information that's on the statement appears on the diagram, right? So you have here they're saying A is 4 and 4, then you can see that's here. Great. And then they're saying E is a point on the diagram, then we see that here it is, right? Also, again, they're saying B is the x-intercept on both. So, where is that? B is the x-intercept on both. We see that, all right? And then it says, what else? B and E are points of intersection. And then I can see that B and E, they are points of intersection. And then they are saying AC is parallel to the y-axis. Now that's new information. This is AC. I see that. With C, a point on F. Where's C? Okay, I do see C here. A point on F. Right. Okay, so when they say we are not allowed to highlight, we are not allowed to highlight the things that we write. But something that's on the question paper, you can highlight it, right? Like the diagrams, we can highlight it. But when I'm writing my answer, where did I write answers? Like here in this case, you see what I did here? This is not allowed, this one. You're not supposed to highlight your answers, things that you write with your own pen on your answer sheet. You're not supposed to highlight that. But the question paper, you are definitely allowed to highlight. Right. Now, then goes to the questions. It says here, determine the value of m. You go to your scenario, you look at where is m. Here is m. Right? So m actually it's the gradient in this situation. We said, how do we find the gradient? We subtract two y values and two x values. So this is the gradient on which line? On this line that I just worked with here. And that is the line of the graph of G. I go to the graph of G. Usually to calculate gradients, I need 2 points. Do I have 2 points in this situation? Yes. I have this point on the graph of G. I have this point on the graph of G. I have A and D. So I'm going to say y at D minus y at A all over x at D minus x at A. They have to correspond. I write coordinates of D, I write coordinates of A. right? So coordinates of D, I have 0 and -4. Coordinates of A, I have 4 and 4. Right? So, and then I make my substitution. So this scenario here, I'll just substitute it down here. M is equal to y at A. Just make sure you go tick it to make sure that you did it right. This is y at A. That's 4. Minus y at D. Oh, sorry, I made a mistake there. The first thing I need, y at D. So y at D is this one, -4. Minus, I need y at A. Here's y at A, 4. And then x at D, this is x at D, 0, minus x at A, this is x at A, 4. This is equals to -8 over -4. This is equals to +2. My m is 2. Right? Then we go to C. What did we say about C? We said C is the y-intercept. All right. So y-intercept of what? For the graph of G. So I go to the graph of G, I look for the y-intercept, and there, boom, I have it. What is the y value there? Y there is -4. So that is my C value. So I'm going to say C is equals to -4. Now look at the marks, 2 marks. So boom, boom. Can move on, right? So afterwards, we want the range. Now, talking about the range, here's how it goes. We are going to say that the range, oops, I need a highlighter. The range refers to all the y values the graph is touching. Just all the y values the graph is touching. Let me remove the small details here. And then you need to bear in mind which graph are they talking about. It's very important. So here, they basically want the range of f. The graph of f is the green graph, right? So this is a question that is so doable, super doable, right? So the range, we are talking about all the y values. I want to see what is the lowest point, what is the lowest y value this graph can touch. Then I go and check this graph. This graph will keep on going down, 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 up until what? Up until -infinity, right? That's where it's coming from. So basically, I'm going to say y is an element of, I say, -infinity. Then I go to the positive y values. How far upwards will this graph go? Well, this graph will keep on going upwards up until +infinity, right? So I come here and say +infinity. Now, bear in mind, you need to start with the lowest value and end with the highest value. So -infinity is the smaller value, +infinity is the higher value. That's how you write it, right? Afterwards, you choose brackets. Every time you write infinity, you always want to use curved brackets this way, because you cannot use inclusive brackets. There's no graph that will ever touch infinity, right? So there you go. This is your range. Oh, there is one y value this graph is not going to touch, and that's why this is 2 marks. So this is the first mark, and there is another part that you're supposed to say. That this graph, as it's moving from this point of -infinity, the one situation it's not going to touch, it's this one. This line, this graph is going to jump. And this line, we call it the asymptote, right? What is the value of this line? Where does this graph have an asymptote, right? We need to know that y value. How do we find that out? We find that out from the equation. We said this Q value here represents your asymptote. Right? So it means here the value, this value that I was looking for, that is -2. Right? So I'm going to say that here. Y does not touch -2. That's where the other mark comes in. Someone is asking, can we say y is an element of a real number? Yes, you can say that. And afterwards, you make an exclusion that y does not touch, the graph does not touch y being -2. We are supposed to put that exclusion because that's the asymptote. All right. Next one. Determine the coordinates of the points of intersection for the two graphs. Now, whenever you hear a statement that says points of intersection, I want you to think some basic things here. Now, at the point of intersection, 6.3, right? Whenever you get to a situation whereby it says point of intersection, you must equate the two graphs. That's what I always want you to remember. So, what are the points of intersection here? The points of intersection are these ones and these ones. What does the question say? The question says, find the coordinates of those points of intersection. And then what do I say we do at points of intersection? We equate the two graphs, right? So we're going to say the graph of f of x is equals to the graph of g of x. All right. And then afterwards, we're going to say f of x. You write down f of x here. All right. F of x is 4 over x minus 2. This is equals to g of x. Right? What is our g of x? We found g of x. First of all, we found m, then we found c. We said our m is 2, our c is -4. So this is 2x -4. All right, you see where those things are coming from. Please do not be confused and ask where are these things coming from. All right, so, and then at this point now you have to remove denominators. And I'm going to write this down here so I can remove this denominator. In fact, I can remove them here. I'm going to say, in this situation, to remove this denominator, I'm going to multiply with numerator x, right? So whatever I do to one term, I have to do it to all the terms. So this 2 must also be multiplied by x. This must also be multiplied by x. This must also be multiplied by x. Everything needs to be multiplied by x. All right. So now this denominator cancels this numerator. What am I left with? I'm left with 4 minus, when I multiply this, 2x is equals to, when I multiply this, that's 2x squared. And then here I have what? -4x. All right. Then afterwards, what do I see? In this situation, what your mind should register here is that here you have a quad trinomial. And how do you see that? Highest exponent is 2, right? That's how you see it. You see it by the fact that the highest exponent is 2. So I want everything now to be on one side. I'm going to say these items, I'm sending them to the left. So these values, I'm sending them to the left. So I'll have 0 on the left side. On the right side, I have 2x squared minus 4x. When I bring this 2 to the other side, this -2 it becomes positive 2x here. When I bring the, let's use this, when I bring the 4, it becomes the negative 4. And then this will be 0 is equals to 2x squared. These two like terms will give me negative 2x, and this is minus 4. Now, what should happen here? What should happen is that I need the coefficient of x squared to be 1. And for that to happen, I'll divide everything by 2. Everything, including the left side, everything must be divided by 2. So now, let's move this. What is 0 divided by 2? That is 0. Oops, made a mistake there. 0 divided by 2 is 0. This cancels that, I'm left with x squared. This cancels that, I'm left with negative x. And 4 into 2 goes 2 times. Then what happens here? Here you factorize. Right? You're supposed to be able to see that. So 0 is equal to, I open 2 brackets. Factors of x, I have x and x. I mean, factors of x squared, I have x and x. Now, because of this sign, let's choose a color here. Because of this sign being positive, it means I must have opposite signs. Because of this sign is negative, it means I must have opposite signs. So I'll put a plus here, I'll put a minus here. And then I need factors of 2 as the last term. That can give me 1. Obviously, that's 2 and 1. But if my answer has to be negative 1, it means the bigger number has to be negative. So which means where there's a negative, I'll put 2, and here I'll put 1. Right? And then what will happen here? Then I equate the things. The factor rule. I have x plus 1 being equals to 0, or I have x minus 2 being equals to 0. Therefore, x is equals to negative 1, or x is equals to positive 2. These are my two solutions. Why do I have two solutions when I had to solve for x? Because actually I was looking for the coordinate of intersection. And in intersection, I have the point at E and I have the point at B. One of them is on the negative side and one of them is on the positive side. So, which will be more possible for me to find those out, right? So I have the first x value being negative 1. I have the second x value being 2. I need to sort those out. I need an equation to help me sort those out. So I'll choose the easiest equation here. Let's use a black pen. The easiest equation, it's this one. It's the straight line equation, right? So the straight line equation says y is equals to, remember I had it somewhere here, 2x minus 4. Y is equals to 2x minus 4. And then remember that I had two x values. I have this one and I have this one. I'm using them. I have x being negative 1. And I have x being equals to, what was the other value? 2. Right. So let's do that. Substitutions. I'm going to say y is equals to 2 when x is negative 1 minus 4. My y is equals to negative 6. And then here I sub 2. My y will be equals to 0. So I have two coordinates. When x is negative 1, my y is negative 6. And then when x is 2, my y is 0. Makes sense this way. It's this one here, because it's on the positive side. And it's this one here, because it's on the negative side. Then I write those answers here. I'm going to say coordinates for E, I have negative 1 and negative 6. And the coordinates for B, I have 2 and 0. Hope we can all see that. There we go. It was quite a long question, but we did it. For 4 marks, this was a bit too much. I think it was supposed to be 6 at least because of points of intersection here. We had to equate them first. All right. All right. Let's remove some few people from your life. Don't be surprised if your life blocks you. It's because you're commenting too much and you're not commenting relevant things. So let's remove this one. Boom. Who else? Let's see. Who else are we removing? Block this one also, of course. Also block this one. Boom. There we go. A few people blocked, 3 people, because they're wasting our time. All right. So this was not too terrible, was it? This was a bit doable. The thing is, the part of finding points of intersection actually was taking, it needed more strength, right? So then afterwards, we have to get to this question. Let's do question 6.4. Now, question 6.4 is straightforward because let's look at what they want. What they want, they're saying that find the situation whereby g of x is bigger than f of x, right? Bigger than means above. Where is the graph of g above the graph of f, right? So I don't think that's a terrible story. G above f, let's come here. Okay, there's a lot of writing here, but I'm going to unhighlight the things, these graphs most especially. There's a lot of noise here, but you will manage to see. Where is the graph of g above the graph of f, right? So here's the graph of g. Let me use the right highlighter for the graph of g. Boom. A situation where that happens, it's here. See this graph of g. Now let me use a lesser line like this one. See at this point, the graph of g is above the other graph, right? And then where else? Also at this point, this one it was tough to see, but there it is. Boom. right? Because at this point, this one, it's right below. And this one here, it's below. And then from there onwards, in other situations, the graph, the other one is above the other one, basically. Like you see here, the graph of G is below this graph here. This graph, it's above, right? And then here, the graph of F is above the graph of G. That's not what we wanted. And then at this point, they switch here. This is where the big switch happens, right? From there, the graph of G gets to be above the graph of F. Same thing applies here. Here, the graph of F was above, and then here, there was a big switch here. And then afterwards, the graph of F went below, and the graph of G went above, right? So the gap is here. So the gap is here and here. And here. So I need those x values, right? I need those x values. Someone says they need us to erase. I can erase the whole thing if that will make you feel better. Let me erase it and re-explain what was I saying. Right, let's remove this noise because I think this is probably disturbing you. I think I'm removing everything now. Let's remove these other things because they might be disturbing you. Right? Boom, boom, boom. Yeah, it's clean now. Right? Many things are out. So, again, let's get to the question. Here's the question, right? The question says, graph of G, here's graph of G, greater than graph of X. So we want where G is above, that's what greater than means, F. Right? Let's remove this one also. Guys, the only simple thing you have to do here is only comment when you're talking about maths. That's all. Like, that's all. I don't see how is that difficult. All right. So let's go to it. Where the graph of G is above the graph of F. You see here, in this situation, G is above the graph of F. Because of here, the graph of F is below here. See what we're talking about? So this is what I expect you to see. Here's the graph of F. The graph of F below. Right? And then, again, look at this situation. The graph of F is below what? It's below the graph of G here. Here's the graph of G. Right? So that's what we want. It's only in this situation that the straight line graph is above the hyperbola graph. Only at this point. In other situations, the straight line graph is below. Like you see here, it's below the cave here. And then you also see here, the straight line graph is below the graph of F there. Only at this situation, the straight line graph is above, and here, the straight line graph is above. So we want those x values. So the first x value is here, starting from E. What are coordinated E? It's this ones here. Remember, let me write them. Coordinates of E, we said they are -1 and -6. Coordinates of B, we said they are 2 and 0. Right? So now when they said determine the values of x, where the graph of G is above the graph of F, this is what you are supposed to do. right? Let's remove this one also. Boom. Now, how many people do we have to block for you to understand what kind of a live session this is? All right. So the writing of it, we're going to say X is an element of, I start with this situation. You see the situation where there's a pink highlighter there? Yeah. The situation starts here where X is -1. And it goes up until this point here where X is 0. Now, do we include -1 and 0? Do we use inclusive values? Well, that one is tricky. Why is it tricky? Because those two values, different things are happening in those situations. Let's start with this. Let's start with the question. The question says I must use the inclusive symbol. This is inclusive, right? But we can only be inclusive as far as it's allowed, as far as the graphs exist, right? So let's come here. At this point, point E, do the two graphs exist? Yes, both of them, they exist. That's where the X value is -1. So I include this value, right? And then at point D, do the two graphs exist? Well, one thing for sure, the straight line graph is passing there. So the straight line graph does exist there. However, the hyperbola doesn't pass there because this is on the y-axis. And a hyperbola on the y-axis, it has an asymptote. So we use a curve bracket there. You see that? So we are done with this situation whereby the straight line graph was above. Now we come to this situation, this one here. Right? I'm going to say and the following X values. Starting from this point, the graphs switch. The straight line graph becomes above and this one becomes below, right? So let's continue with it. Do we have to include this coordinate here? Yes. The graph of F passes there and the graph of G passes there. So we are using square brackets. What is the X value there? 2. And then how far will the graph of G be above there? It will keep on increasing and this one will keep on being below up until infinity here, up until infinity here. So which means this will happen up until infinity. What bracket am I using with infinity? Well, you always use a curve bracket with infinity. Let's see how many marks was that. This was 2 marks, which makes sense that this part of the answer is 1 mark, this part of the answer is 1 mark. Do we all see that? So the next question, let's remove all the things because I learned that with too much chaos, things are not understandable. Right? The answers I wrote there, I'll just keep them there. They are actually super useful. So now, the next question says, as I was saying, the length of AC, right? What we are learning about AC is the following. I want you to pay nice attention to this thing. Use another notation, say, I already erased, I was going to use it. Set builder notation. The one that I use now was set builder notation. The one you're talking about, the other one, we call it interval notation. Just lazy to do it. But where I use square brackets, you're going to use an inclusive symbol like this. And where I use curve brackets, you're going to use an exclusive symbol like this. Right? So yeah, basically that's that. Okay, we were saying this question wants you to find the length of AC. Right? And I want you to see where's AC. Here's AC. Do we see where is AC? And they said that AC is parallel to the y-axis. Makes sense. It is parallel to the y-axis, which means we should ignore the x values because of x, y's. In terms of x values, this graph is, this line, this point has the same x value as this point. What am I saying by that? It means whatever x value is here, it will be the same here, and it will be the same here, right? Now, what is the x value of this line? Where is this line passing? I have a coordinate here. I have a coordinate here, which is very simple. The coordinate, it's in the form of x and y. So which means at this point, my x value is 4, right? And now that also gives me an x coordinate of c. It means for c, I already have the 4. I just need the y value there. All right? Where do I find c? I find c on the graph of f. And the graph of f has an equation, which is 4 over x minus 2. Right? So what are we supposed to do? We're going to say we are subbing an x value here into the other things. So I'm going to say, I'm going to rewrite this in terms of y. So this is y is equals to 4 over x minus 2. Right? So what happens there? Where I see x, I substitute with this x value that I have for c. So y is equals to 4 on x, I substitute with 4 minus 2. This cancels each other out, but it's not 0. It becomes 1 minus 2, which gives me a y value of negative 1. Therefore, coordinates of c, I have x being 4 and y being negative 1. Right? So I want you to understand, what does that mean? What that means is now that the distance from here up until there, in terms of from the x-axis, the distance is this y value, which is 4 units upwards, right? And then the distance from here up until where c is, it's how much? It's whatever this y value is. So it's 1 unit downwards, right? So the total distance, it's the 4 units upwards and the 1 unit downwards. So total distance, therefore AC is equals to 5 units. Hope that's understandable. Someone is saying, must we write the 5 units or just 5? You must write the 5 units because we're talking about distance, right? Just write 5 units. Next part. Here are the calculations. And then in those calculations, you will see where the 5 units come from. So we said here, the distance from A up until the x-axis, it's 4 units. The distance from the x-axis to C, that's 1 unit. So in total, that's 5 units. Can we move on? We can move on, right? I think I shouldn't make you guys sleep late because you're writing tomorrow. And you might need to have some time to yourself. So I think latest will finish at 9. Say, is this similar to what is expected tomorrow? I don't know what is expected tomorrow. I'll only get to print the question paper tomorrow. I made sure that I don't get to see it. So tomorrow I'll arrive early at work, print the question paper, then hand it to you. Someone is asking, are we writing a district paper? Yes, we are writing a district paper. So here's another question here. Now, this is a question that actually wants you to... Do they want you to draw? I think so. Let's see. The question says, number 1, you are given the equation of an exponential graph, and the equation goes as follows. Here's the equation, right? So before anything, I want you to remind yourself, what does the Q represent? Asymptote. The Y value of the asymptote, right? And in A and B, they tell you shape, right? B tells you whether the shape goes to the left or right. And A tells you the shape, whether it's a shape, right? Shape. And then A tells you the shape if the graph goes up or down. That's how you should interpret the equation of this thing. Right. Someone is saying, please lick the paper when you get it. How will I lick the paper, Chief, if I'm printing it out the time where you are writing? Chief, you don't think? So, right. Now, okay, let's move on forward. They're saying you are given the following information. That your A value is found between 0 and 2. Right? This is our A value. And they're saying, now, the most important part, it is an integer. It's an element of an integer. What do we know about integers? Integers cannot be fractions. Boom, there we go. Right? When they say integers cannot be fractions, it means they're only whole numbers, right? And then when they're saying A is found between 0 and 2, it means A is positive. Okay, good. They're saying the range of this graph, which is the graph of H, it is any value above -2. Now let's imagine this thing. We can already see it now, right? So where's -2? Right. And then they told us that our A value is it is a positive value, right? Which means the graph is facing upwards. Now we don't know where the graph is going, right? So the graph can be going this way, or the graph can be going this way, because we don't know the B value, right? So That's the thing. And then they're saying A is a point on the graph whereby we have, what is this, 1 and 0? Okay. Now, the first question says, write down the equation of the asymptote of H. Asymptote, remember we said you find them using Q. Your Q value, that's the Y that's the Y value that the graph will not touch. Right? So, how do you do that? We know that this graph is not going to touch -2. So our asymptote is Y equals to -2. That's the point where the graph will never touch. So, boom. There's the mark there. Right? And then afterwards, we have to find the equation of H. We can move on, right? So they said our A value is positive. It's a number between 0 and 2. All right. We know that the A usually doesn't have a value. They will tell you that A is -1 or A is +1. Right? And how do we know that? Because they said A is an integer. Right? That's why we are saying A cannot be, if it's a number between 0 and 2, and then we are saying A is an integer. It's above 0, but it's less than 2. Obviously, A is equals to 1. That's what they're telling us, right? So we know that our A is 1, right? We know that our Q is equals to -2, because that's our asymptote. Now, so far, our equation looks like Y. Where am I taking the equation? From this point here. Y is equals to our A, which is 1, multiplied by B raised to X, and then our Q value is -2 minus 2. Right. So then what happens there? We have to substitute one coordinate so that we can find the B value. Let's do that. Let me remove other things here that are not necessary, because they might mess us up. So I need to substitute one coordinate, and where is that coordinate? It's this one. They told us that A is a point on the graph. So I'm going to say substitute 1 and 0 into the equation. Let's do that. Where there is Y, we'll put 0. So 0 is equals to 1 multiplied by B. Where there is X, we'll put 1. So here's 1 minus 2. What do? We transpose 2, that it goes to the other side. So we have 2 is equals to B. Boom. Now let's write the equation. The equation is Y is equals to our A value, we said it's 1, multiplied by 2 raised to X minus our Q, which is -2. There we go. And then 7.3 says, write down the y-intercept of H. So y-intercept. First of all, we know the equation. The equation is y is equals to 1 multiplied by 2 raised to X minus 2. Number 2, it's the y-intercept. So we must let X be equals to 0. You have to write that statement. It ends you a mark, right? So you have y is equals to 1 multiplied by 2 raised to 0, because we are subbing X with 1, with 0, and minus 2. Then y is equals to 1 multiplied by, what is 2 raised to 0? 2 raised to 0 is the same as 1 minus 2. What is 1 times 1? That is 1. The answer here is negative 1. Now, bear in mind, they were specific. They want the y-intercept. And now in the y-intercept, you have to write it as a coordinate. So you're going to say, therefore, your y-intercept is 0 and negative 1. X is 0, y is negative 1. I hope that is okay. And then, of course, we cannot do maths and not do a Gauteng paper, right? So I have to throw in a bit of a Gauteng paper there. We'll do the algebra component of it, because I'm actually expecting you to get high marks on algebra. All right. So let me send myself a Gauteng paper. Boom, boom, boom. Quickly creating it. I think it's this one. Not the one. Oh, see, I'm quickly getting a Gauteng paper, and then so that we can do it, because it doesn't help for us to practice and not use a Gauteng paper. So Gauteng papers they're actually more challenging than other papers or than other provinces. All right. So let me quickly send it, and then we do it. And then yeah, and then you guys go back to study. All right. So here's what we have. Number one, we have this one, whereby they ask you, without the use of a calculator, right? Tell us between which two integers does the following surd lie, right? So basically here, actually, I expect you to use a calculator just to get things fast, right? But you can also still do it without a calculator. Now, how do you do it without a calculator? You first check a perfect square that is right below this number here, right? So 112, a perfect square that is there, it's 100, right? So I can put 100 under a square root there, put an inequality sign, put this value here, 112, right? And put this. And afterwards, I want a perfect square that is above this 100. A perfect square that is above this is it 121? Let me check out with my calculator. 121, it must be a perfect square. Square root of 121. Yes, 121 is a perfect square, right? You're going to write it this way because of this part has a mark. You are showing us that this 112 Square root of 112, it's found between the following perfect squares. And then now you must write the integers that are between this third that you see, right? So we're going to say the integer here is 10 and the integer here is 11. Another mark. Boom. This one I expected not to defeat you. Then give me a conclusion. Therefore, the square root of 112 lies between 10 and 11. All right? So you give me that. So that is it. Then afterwards, there's a question that says simplify. And I realized on the previous things, we didn't actually do much of simplifying things. We had other questions, yes, of course, and we did have simplify in a different way, but I like this kind of simplifying. Because if this is where you collect marks, that's if you get a question that allows you to collect marks. So here what you do, you multiply the binomial with the trinomial. You don't multiply the trinomial with the binomial. You want to take the binomial and multiply it with the trinomial. So what do? You take the first term of the binomial, you multiply it with everything in the trinomial. How does that make sense? You take 3 first, you multiply it with x, that's 3x. Take 3, multiply with negative 1, that's negative 3. Take 3, multiply with x squared, that's positive 3x squared. Done with 3. Now you go to negative x. Bear in mind, this is negative x. Negative x multiplied with x, that is negative x squared. Well, let me choose a different parenthesis. Okay, it's fine. Negative x multiplied with negative 1, that is positive x. And then negative x multiplied with x squared, that is negative x cubed. All right. Then you work with like terms, but you organize the expression. You have to. The one with the highest degree, with the degree of the expression, the one with the highest exponent, you start with it first. So negative x cubed. And it doesn't have a like term, so we keep it like that. Then you go to the ones that have the second highest exponent. So I have negative x squared and positive 3x squared. When you add them, you get positive 2x squared. All right. Then you go to the ones that have x's. You have this part, you have this part. Positive 3, positive 1, that's positive 4x. Right? Then you are left with this part here, negative 3. There you go. Your answer must be organized properly. Right? How many marks was there? 2. Nice. Hope we all can see that. We can move on, right? You guys good? Yes, okay, let's move on. And then afterwards, we have this part here. Let me remove these other items. Then we have 0.2.2, right? You have x plus 1 over 2 minus 1 minus x over 17 plus 7 over 34. Now, there is something that must bother you here. First of all, you must understand that this is not an equation. So you cannot remove denominators. All right? It's not an equation, it's an expression. You cannot remove denominators. However, you can still make denominators the same. The numbers you have a 2, you have a 17, you have a 34. These are your denominators. So when you have denominators and you want to make them the same, you are looking for the LCD, lowest common denominator, right? So where these numbers meet, they all meet at 34. By a person who's in grade 10, I expect they know how to get there, right? You're looking for multiples of 2, 2, 4, 6, up until you get to 34. Here you look for multiples of 17, it's 17, then 34, right? Then here it's 34. So this is your LCD. So I want to get every number to 34, and then that's how we do this. So here I'm going to say x plus 1 over 2, and then the task now is to get it to 34. How do I get 2 to 34? I'm going to multiply this by 17, but it must be in the form of 1, right? So it doesn't change the number. When you multiply something with 17 over 17, basically you're multiplying it with 1, right? So, and then the next part, I have 1 minus x over 17. This 17, I need to get it to what? To the LCD of 34, right? So I'm going to say, how do I get 17 to 34? I multiply it by 2. 2 over 2, right? Then we get to the next part again. Plus 7 over 34. How do I get 34 to 34? Well, it's already at 34, so I leave it there, right? So here I have a binomial. So remember, what are you supposed to do with binomials? Binomials, you're supposed to put them in brackets this way, so you can work them out properly. So 17 by x, that's 17x. 17 by positive 1, that's positive 17. All this, it's over 17. Minus 2 multiplied by 1, that is 2. 2 multiplied by negative x, that's negative 2x. All this over 34, not 17, 34. Surprised nobody saw that. Plus 7 over 34. This way. Let's remove this. So now what happens? Denominators are the same. We put all of them under one denominator, 34. So I have 17x plus 17. Then I'm subtracting this binomial. So subtract a binomial in brackets, right? Plus 7. Let's use a more visible pen. This will be 17x plus 17. Distribute the negative. That's negative 2, positive 2x plus 7. All this over 34. So 17x and 2x, that is 19x. And then 17 plus 7, that is 24. 24 minus 2, that is 22. Right. Is there something we can do? No. There is no common factor between 19 and 22. So this is your final answer. Boom. There we go. We can move on, right? We can move on. Boom, boom, boom. Let me switch this account to the main account. I think that's the problem. Oh. Because when we are subtracting, like where is it? Here. When we say minus this, the minus applies to 2 and it applies to 2x. right? I remove this one. Boom. Remove the person also. Who else to remove? Yes, I hate the fact that I have to keep on removing you because you can't behave. Let's go to the next question. Tomorrow's paper will be out of 100. It counts 60% to your year mark. I mean, to your entire work for grade 10. It counts 60. No, it counts half of that. It counts 30% because you still have to write another paper. So the paper you're writing tomorrow, that paper alone, it weighs 30%. The paper you're writing on Monday, it weighs 30%. Right? So together, these papers, they weigh 60%. Yes. What was I saying? Yes, we said we are moving to the next question. So here's the next question. Let's use a red pen. It's more visible. Boom, boom. So 1.2.3, we have a question that we see. It taps onto the part of exponents. So we have 4 raised to x plus 3 multiplied by 8 raised to 1 minus x multiplied by 2x minus 9. This is a monomial. These are 3 numbers joined by multiplication. So now they are one thing. Remember, multiplications, they join terms. Right? So what's happening here is that I see that the bases are not the same and I have variable exponents. So I need to make bases the same. How do I write 4? I'm going to write it as 2 squared. But 4 had its own exponents. So I'll bring them here. That's x plus 3. Multiplied by 8. How do I write 8? As 2 raised to 3. And because it also had exponents, I'll bring those exponents here. 1 minus x. This one is already in terms of base 2. So it doesn't need any changing. All right. So afterwards, I remove the brackets. So I have 2 times x, that's 2x. 2 times 3, that is plus 6. Multiplied by 2, 3 times 1, that is 3. Minus 3 times x, which is 3x. Multiplied by 2 raised to x minus 9. Beautiful. In fact, this is a simple paper, this one. Or these are simple questions, the ones we are doing. All right. Then what do? Bases are the same. You add the exponents. You represent with one base. You write out the exponents. You have 2x plus 6. Come to this one. Plus 3 minus 3x. Come to this one. Plus x minus 9. And then you add the like terms. This and this, it's 3x. This, it's minus 3x. So basically, they cancel out. Right? And then I have this and this, that's 9. This is negative 9. So also it cancels out. So everything is cancelled. What happens? It means I have 0 here. What is 2 raised to 0? 1. Thank you, guys. I see that there's a person who got it right. Thank you. We can move on. Please confirm that we can move on. Yes, thank you, Bukamoso. Let's erase this. Right. So now we have to get to the part of factorizing. I'm sure by now, guys, you know we had strong videos in the beginning of the year about factorizing. There is no need for me to create lessons about factorizing again. So if you don't understand factorizing, just go right here on our YouTube channel. Go find grade 10 content on the playlist. You'll see there is a factorizing video there. All right, let's get to this part. Type of factorizing quad trinomial. How do you know it's quad trinomials? We have three terms. Oh, it's not only quad trinomial. Because of quad trinomial, the highest exponent must be 2. So here, the highest exponent is not 2. Let me write this out. This is kind of interesting. Plus 21x. What am I seeing here? I have x, I have x, I have x. So take out a common factor x. You'll be left with x squared. Minus, here you'll be left with 10x. Here you'll be left with 21. Right? And then there's no way they're going to give you this thing whereby you take out a common factor and get 2 marks. You're in grade 10 now. They are not going to do that. It means there's another step of factorizing from here. There's no way we are going to give you 2 marks. Just put this. Right? So the middle part, the part inside the brackets is factorizable. So we deal with that. So you keep this outside. You don't drop it. You keep it outside. Then you use square brackets now because you're going to need curve brackets. So you put curve brackets here, this way. Right? And then you do the factorizing thing. Factors of x squared, it is x and x. Right? And then here you have a positive sign. It means you must have same signs in your brackets. The same signs, because this one here is negative, it means you're going to have a negative and a negative. Factors of 21 that give us 10. Well, there are only a few factors here. 1 in 21, we have 3 and 7. We can all see there's no combination we can make with 1 in 21 to get 10. But 7 and 3, of course. It doesn't matter which one goes where, because, they're all negative anyway. And then the second mark comes here. There we go. Are we sorted? Sorted. Oh, someone asked the question saying, can it be solved by factorization or quadratic formula? Who taught you quadratic formula? Quadratic formula, it's not wrong. It's grade 11 content. If you know it, you can use it. It's okay. It's maths anyway. If you know the quadratic formula, you can use it. It's grade 11 content though. Oh, from Sweden. All right. I get you. Okay, let's move on because I think we are running out of time. We have 13 minutes left because I said I'm going to knock off at 9 instead of 10 now. And then my whole point was for us to do as much algebra as possible, because thing is, algebra is doable. Functions, they need a person who's prepared for them, because the functions are not difficult. They want you to practice them. All right, so here's what I have. This situation, I see that, oh, these are 4 terms. Whenever I have 4 terms, it's grouping of terms. All right. So now I'm going to write these things out. And then I group them. When you group them, remember you must have a binomial at the end. Separate them with a plus, always. Just separate them with a plus in this beginning step. Then here you take out a common factor. No, not common factor. Here you want to, the only thing you can factorize, the only thing you can do here is factorize. This is difference of 2 squares. Right? So what you're going to write is that for this part, you're going to use 2 brackets. Only for this part. And then this part will come down here. Plus x plus z. See what I did there? Right? Then back to this story here. Let me use a different color. Back to the story here. We said this is difference of 2 squares. Since it's difference of 2 squares, let's use a black color here. One bracket will be positive, the other one will be negative. Factors of x squared. All right, factors of x squared, that is x and x. Factors of z squared, that is z and z. Now, it isn't showing fully. Angelique says this is not showing. Angelique, it does show. Like I opened, I have a phone that is open to this YouTube channel with a different account, so I can see it shows. The way you see it, it's the way I'm actually writing it. Like what you see is what I see. All right. So, and then we have, I want to take this down here because I need it. I want to explain it. And then plus here. Right. So what's happening here is that I'm realizing that I have 2 terms. And then in these 2 terms, this part here, it's the same as this part here. Right? And then basically, like, this is term number 1. This is a term on its own. And this is a term. Hence, I'm saying I have 2 terms. Right? So if I take this out as a common factor, so I'm taking a bracket out as a common factor. So I'm already using too many curved brackets. So if I take this out as a common factor, what's remaining inside, I'll keep it in square brackets. Do we all see why I used square brackets? I'm taking a curved bracket out as a common factor. So what's remaining inside will be 2 curved brackets, right? So what's remaining inside now? What's remaining is that I'll be left with this part here. Boom. Right? So when you're in this situation, if you leave the answer here for me, I can still take it because you factorized. Your answer is left with brackets. But then if inside those brackets, you end up saying, let's keep this outside. But I'm saying if you end your answer here, I will give you full marks because of this is factorized. So that's all I wanted from you. I never wanted you to simplify or anything. But if you take it further and then you say this is x minus 7 plus x plus z this way, because actually there is nothing holding the brackets together here. The brackets can fall off. Right? So I would say this will end up as x and x giving you 2x, z and z cancelling out. Wait, I made a mistake, sorry. I'm surprised there's no one correcting me. Whoa, you guys. Surprised there's no one correcting me. So here when I took out a common factor, boom, and boom. Back to this one, right? Like, okay. Here when I took out a common factor of x plus z. On this part, I was only left with this bracket, right? And then on this part, when I took out x plus z, this bracket, entire bracket as a common factor, I'm left with 1. Yes, this is how it was supposed to be. Right? This is how it was supposed to be. So now, again, if you leave your answer here, I'll accept it. Because you factorized. You did all you had to do. And then everything is left in brackets now. Packaged properly. Right? So, but then if you end up continuing this further, and then you say to me that in this situation you are realizing that there is nothing holding these brackets together. Oops, mistake there. Like in this situation, if you realize that there is nothing holding these brackets together here, and then therefore you want to simplify them, you say x minus z plus 1. I can still take it. I can still take this answer. But again, if you end up here only at this step, if you end up at this step, still perfect by me. So both answers are correct. All right, we can move on, right? Because of my time is flying. I'm left with 5 minutes. So I don't actually have a lot of time. And there's some nice questions here. Let me see their functions. Oh, nice one. Super nice. Another question. Very nice. Some probability and finance there. Guys, we did probability and finance around term 3, term 4. I expect you not to disappoint me there. Yes, Skeleto, we are almost done. I have to give you time to go study on your own also. All right? Because I cannot actually keep you here up until 10. Because you actually have to start. If I'm doing algebra with you now, you have to go back and polish your finance, polish your probability there. All right? Remember how to draw Venn diagrams, things like that. Yeah. All right, I ran over a few things. If I touched something here on algebra and functions that triggered you, you have to go fix them. Kuklano, we did functions. Okay, let's take the last question. Eliminating this one. So this is a level 4. You don't benefit you anyhow, whether we do it or we don't do it. The examiner usually doesn't repeat level 4 questions. Boom. Which one can we do here? Out of the ones that are remaining, these ones. Let me slide it up so that you see it. Yes, what can we do? One point five. 1.5. I think we did something similar to 1.5. Kabalo 1.6, we said we are removing it because there's no point. There's no point in studying level 4 questions tonight. They hardly repeat them. They create them, like they find a level 4 question. 0.5, 0.42. What about 0.41? It's doable. Point 0.5 and 0.42. All right. Okay, that's mostly what we have. Okay, let's quickly do them. Let's do both then. Let's do both. Starting with 0.42, right? So 0.42 we have this pen. Let's put it here. 1.4.2, it says 3 raised to 3x minus 1. This is equals to 27 raised to x minus 18. Let me remove this thing here. It's distracting me. Boom, boom, boom. Yeah. So, and then afterwards, I realized that I have different bases. I have so many bases that are different. So I have to work with that. First of all, I see I have base 3. Base 3, basically, like it's the simplest base. I cannot change it anyhow, right? So I'll keep it this way. 3 raised to 3x minus 1. Do I need to separate them? Well, I don't know now. I might need to separate them, but for now, I don't know. So I'll keep on with it this way. This is equals to, can I write 27 in a different way? Yes. You take out your calculator, you press 27, you press equal sign, you press shift, you press fact, and then you will see that it tells you that 27 is 3 raised to 3. Right? So we have 3 raised to 3 as 27. 27 was carrying exponent x. So the 3 raised to 3 will also carry x minus. And then 18, you do the same thing. You press 18, equal sign, shift, fact. You will see that it writes 18 for you in terms of 2 multiplied by 3 raised to 2. All right. So that's what you want. And then afterwards, you're going to say, let me remove these people. I can't even see proper comments. Please wait for me a bit. Removed. Put user on timeout. Yeah. Right. Where was I? Yes. Thank you, Geleto. See that? And then afterwards, I remove brackets. So I have 3 raised to 3x minus 1 is equals to, I multiply these exponents together. This is 3 raised to 3x minus, I have 2 multiplied by 3 raised to 2. Are we good? Then what needs to happen here? There is one thing that is very possible here. What needs to happen? Any ideas? There is something you should be able to see there. Boom, 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 boom. Something you are seeing? Separate and drop bases. Separate and drop bases. Divide by the negative 2. Get rid of the 2. I don't know. It can't be like that. Okay, here's what you want to do. You see that, oh, oops, mistake. You can see that these two things, they are almost the same. So let's put them at the same place. I have 3 raised to 3x minus 1. Transpose this to the other side. That's negative 3 raised to 3x. This is equals to negative 2, 3 squared. In other words, I'm going to say, okay, now the question I was asking myself, do I need to separate this? Yes, now it looks like it's a must. I need to separate them. Right? And then afterwards, I consider this, and wait, fix this. This is 3x. Right? So this and this, they're the same. Right? So I take them out as a common factor. I'm left with inside here, this one. And then here I have minus 1. This is equals to negative 2, 3 squared. All right. Then we continue with that. I'll be having, this is a lot of work here. It's a lot of work. I'll be having 3 raised to 3x. Here I have 1 over 3 minus 1. How can I write the 1 in terms of 3? 1 is the same as 3 over 3. So I'll write this 3 over 3. It's equals to negative 2 and 3 squared. By now, I'm even questioning myself whether I needed to change this to that. We'll see. So 3 raised to 3x is equals to, bases are the same. I mean, denominators are the same. I keep one denominator. 1 minus 3, that is negative 2. This is equals to, now I can see that actually I never needed to separate this. So I'll take it back to negative 18. Right? And you'll see why. So then I have 3 raised to 3x multiplied by negative 2 over 3. This is equals to negative 18. So now I want to remove this by multiplying it with its reciprocal, which is 3 over negative 2. I do the same here, 3 over negative 2. Because this is a fraction, I also have to make this a fraction. These ones cancel each other out. Let me show you how. Denominator cancels numerator, negative cancels negative, 2 cancels 2. I'm left with 3 raised to 3x is equals to, here negative cancels negative. I no longer have negatives. I have 2 into 2, it goes once. 2 into 18, it goes 9 times. Right? So I'm left with 9 multiplied by 3. This is 3 raised to, oh, I forgot you can see here at the bottom. This is 3 raised to 3x being equals to 27. So 3 raised to 3x is equals to 27 is the same as 3 raised to 3. Right? And then you drop bases. You're going to be left with 3x is equals to 3. Divide both sides by 3. Therefore, x is equals to 1. So there we go. We can move on, right? Let's remove this one. All this for 4 marks. Oh, well, actually, I'm taking longer steps. But, yes. Block this one for 24 hours. You see the way I'm so considerate. I'm not even blocking you permanently. Just blocking you for 24 hours. Someone is saying when you get the negative 2 over 3 to the other side, it becomes a reciprocal, but the minus doesn't change, right? Yes. Because basically what you did here, you introduced a new number. You introduced, this number was not there. So this number is 3 over negative 2. Whatever you introduce on the left, you must introduce on the right. So you do the same, 3 over negative 2, right? This was not an additive inverse, whereby you are taking a number from one side, you are taking it to the other side. No. You are multiplying the left side with a new number, which means you must also multiply the right side with a new number. Right? You're welcome, Gavelo. Welcome, guys. So, last question. Last question. You know what's one thing, right? When you are writing an exam, it doesn't necessarily mean that the last question is difficult. Actually, the thing is, by the last question, you are tired because your mind, you've been thinking throughout. So questions that demand a lot from you. When you're looking at a question, you know you have to stop and think. I don't want to see that. I don't want to see you in a moment whereby you are looking at a question and you are sitting, thinking. No. Go to the questions that don't need that. Go to the questions that you can solve without even thinking for 1 minute. You are looking at it, you know that this is the answer. Right? Because of this thing of you pausing and thinking for like 3 minutes before you answer a question loses you a lot of time. By the time you get to the end of the paper, it's not difficult. It's you who does not have time because you used it thinking about questions you don't know. And therefore you lose marks on the questions you don't know. And you lose marks on the questions you know. Right? So there are no marks on the questions you don't know. Marks are on the questions you know. Focus more of your time on the things you are able to do. You will come back to the ones you don't know. All right, last question. Where is it? Is it this one? Yeah. Solve for x, and it's an inequality. Right? So let's put it here. There we go. Here's a nice question for 3 marks. And I'm sure you are hoping that, okay, I use a shorter step because it's 3 marks now. I'm going to use a step that is long so that you can understand it. So first things first, I want to remove a denominator. So I write this thing 2x minus 1 over 3. Negative 3 here, negative 1 here. For me to remove denominator 3, I'm going to say multiply this with numerator 3. Now, mind you, I'm introducing a number into the situation, right? So now, whatever new number I'm introducing, I have to introduce it now to all the numbers that are there on all the sides. Now, remember on the previous question, what did we say? We said that only when you multiply with a negative or when you divide with a negative, the signs are affected. But now we are multiplying with a positive number. So I don't touch the signs this way. Oops, that's a mistake there. Yes. Also here, I'll multiply with 3. Right? When you introduce a number, you introduce it everywhere. So then afterwards, you solve things out. Boom, here I have negative 9. Denominator removed. Right? Negative 3. Right? Then what do I have now? You have to imagine now that in this situation, you are dealing actually with two equations. Or you are dealing with an equation that has two sides. Whatever you're doing anyway, you have to do it everywhere. For example, we want to remove the negative 1. The negative 1 has to go. But the nature of the way it leaves, it goes to this side and it goes to this side. So, here's how it will be. I need the space. You're going to be left with 2x. When you send the negative 1 to this side, you're going to have negative 3 plus 1. Then here, when you send the negative 1 to this side, you're going to have plus 1. Let's put it properly. Oops. You're going to have negative 9 plus 1. This is the 1. Right? And then you have 2x. This will be negative 8. This will be negative 2. And then boom, I have to remove the 2. So bear in mind, I'm dividing with a positive number here. So because I'm dividing this part by 2, every part deserves to be divided the same. Every part. What I do in the middle, I do on the left and on the right. Right? Let's remove this. Right? Okay, let's go. Yes, thank you. Let's remove this. This part was not there, this one. This one is not there, not there, not there, not there. All right. And then this cancels this cancels this. I'll be left with x here, less than. And then I have negative 1 on this side. Here I have negative 4. Boom. That's the final answer. I don't think it's that terrible. I think it was doable. I think the previous question was more interesting than this one. This one, it's just doable. All right. So guys, there we have it. It was a nice session. Please continue studying. You just have to cross-night this today. I forgot which session are you writing tomorrow. First session or second session, I just forgot. But kill yourself for the last time today. I mean, this is maths, guys. It's maths today. It's maths on Monday. We're going to have a live session again on Saturday. Saturday from 6 up until maybe around these times. Or maybe around 10. So come back on Saturday and let's work. And then I hope you guys are well. And then thank you for the subs. We are now sitting at 995. We're almost at 1K, right? So that is good. Very good. All the best for tomorrow, guys. All the best. Like, All the best. That paper, district papers, how are they? It needs to find you ready. You need to collect on algebra and functions. Of course, and other things, right? But those ones, they are worth more. So please work things out. I believe in you guys. Goodbye. Good night. So, end of the session. How do you end the session here? Oh, yes, here we go.